Hello, good afternoon. My name is Rafael Monnerat. I'm going to talk about hyperconvergence. Hyperconvergence meets big data. I work for NextID from Paris, and I was aboard today hyperconvergence that we do with SlapOS and how we deploy big data projects using Wendelin, how we deploy it, how we normally upload data, and I will start to make quick demos in the end of the presentation. So the goal of this presentation is to be a bit modular. Not necessarily you are going to use SlapOS, and not necessarily you are going to provide big data with Wendelin. So, but the merge of the two that we have been using, it's somehow the key that we could imagine for future englobate and hyperconvergence with big data in order to collect and automate the deployments for big data in the Internet of Things. So this presentation, so these two tools and this presentation reflects how NextID works with their customers. So NextID is one of the largest open source publishers in Europe. Despite the fact it is a small company with just 30 or 40 employees, we could produce a big amount of open source softwares. And I will board the two of them today. This is just what they stack that I'm going to base myself on today. And these tools were mostly created to englobate a need for a customer that couldn't find an alternative solution for the problem that it has. And during the presentation, I will give some examples of how SlapOS was designed and implemented, and during the evolution of the tool was targeting to cover topics which don't exactly are covered by other tools. So this is just a list of a stack which is fully open source and mostly based on Python, except the FluentD one, which is actually written in Ruby, and it's not a software that was written by NextID. But in the market, we couldn't find an as reliable solution in Python these days. So Wendelin core is to provide out of core PyData, which means that we can process data which is larger than the RAM of the computer. Neo is a distributed database. For those who knows ZOP, it's a distributed ZODB. EuroPython it's an open source ERP. Not so exciting on this presentation. SlapOS is the tool that I will present in follow. The Resist is something that we developed to provide mesh, interconnected mesh networks worldwide. FluentD is to collect data, and Scikitlearn is for do machine learning and others. So this was the start of this SlapOS. It started in 2009 or 10. I don't remember exactly the day. And when it was built for the first time, we were proposing on that time to put servers in people's home. So we designed a system that could be distributed in a way that it could work in more than one data center. So it could work in Amazon or Hackspace, OVH, or any other provider. And also to cover to be able to host services in people's home or office in a distributed way. It starts to work very well, and then it, with the Internet of Things and other projects that it's coming up, the model was the SlapOS was became a tool that could be installed on machines that were in cars or trucks to provide a mobile cloud. We have a project ongoing on this. It can be used to host services in people's boxes. Like in France, there is a free box, and so you could produce equivalent of it with SlapOS. It's being used in the turbines, to wind turbines, for collect data in order to inform when there is a need for preventive maintenance, and also it's also used to create Internet of Things routers. You get an Raspberry Pi and you install it, and then you can collect data over the several devices that are eventually connected in the network in order to collect data or manage certain services at your home or elsewhere. So now we become beyond the data centers. We can manage at the same time mobile cloud and normal CDN using data centers, using exactly the same system without significant modifications in any of the parts. And it's important to show that the SlapOS can provide nodes everywhere, and it uses a central server. For now it's only one, but in future it can be more than one master to control any amount of computers and devices which are with SlapOS installed. So just to illustrate a bit, so what is the SlapOS? So SlapOS is composed by whatever Linux is installed, whatever Linux available today as base. So there is three core components, that is the SlapOS core that coordinates everything. We are based in build-out, so we can reconstruct a software from scratch, or use some cache automation to share already compiled softwares between two machines which are based on the same architecture. And we use Supervisor D for manage the process. On top of it, so this is what is present on all machines. So on top of it, you have the soft releases. The soft releases are some kind of equivalent of a group of packages that are placed in a special way in the system in order to provide binaries to run whatever service that binaries are supposed for. And you can have several configurations in one machine. So the same machine can have more than one version of MariaDB or Apache or word process running at the same time without conflicting each other. So the soft releases itself don't provide any running process. It's just software there. And And we have, the software instances are the ones that runs the services. So you can imagine that when you install a package, it only provides the binaries, and on the instance sides, it will tell how the binaries will run, how the service will be composed. And in the software instances, it's a bit similar as a kind of microcontainers. So there are containers, but they are more light in a way that it don't provide overhead of recopying the same group of files everywhere. That's why there is this major separation. So this represents, for example, one machine running anywhere. It can be a machine in a data center or my laptop, which I move around anywhere, and can be hosted in a car if there is a need for it. And one important thing to remark is that it can run at the same time VMs or virtual machines, so a bit like what OpenStack does, and also other services which are not virtual machines, which are not virtualized, it's just processes. So a machine can compose many different kinds of services in a distributed way. So a cluster can use more than one machine, several machines. It depends how the composition will be configured. I will later on this presentation I will show the case of the big data with Wendelin. So based on this configuration, we can provide at the same time, using sharing services, sharing computers, we can supply several projects and run them all at the same time, sharing the machines. And they are, by this list, you can see that they are significantly different in terms of goals. So we are running, for example, today a CDN worldwide, which is present in China. So we have services in China. So we have KVM clusters for big data in TerraLab, which is a French project that provides big data for large French companies at the Institut Mines Telecom. So we have Wendelin for big data, which I will mention in the sequence. It's being in production today to provide preventive maintenance for wind turbines in Germany. And we have development, we have distribution test nodes, some kind of equivalent of Jenkins, distributed in several machines worldwide. So we have the automation of, we have a system that can produce VM images. So we automate, I don't know if people know or not, we automate the work that Packer does for generate VMs. So we can generate pre-built VMs. And we also use to provide the Chromium OS images for Chromebooks. So we have our own distribution of Chromium OS, which is called latOS, and we use SlapOS also to build the images for ourselves or for the persons that want. And for make this works, it requires to leverage the way to install it everywhere. So if we have 20 different ways to install the same thing based on different architectures, it will require much more effort to deploy anything. So I will come back to this one. So how we do the deployment of it? We have a one-line installation script that will ask you if you want to connect to the master. So if you want to connect to whatever master, you can tell which one. You connect your device to the machine. For example, this laptop is connected to the master. So I can use master to deploy services on my laptop. Or if you have a mobile cloud, it's the same way. I can control machines based on master, deploying them, deploying whatever service to whatever machine it's connected to there. So we use Ansible, which is also a Python tool, to automate the setup of the node. It allows us to, with the same line, we can set up a Raspberry Pi, a laptop, like in a Chromebook, or a production data center. So in this way, the Ansible take care of the particularities of the system that is being installed. So we can support a very large amount of Linux distributions, for example, just by using this command. If your preferred distribution is not supported for whatever reason, we will be happy to add. We just add on demand. So you don't have to actually connect always to a master. You can deploy a standalone node by just skipping the questions and running these two commands here. So if you type SlapOS node configure local, you get your computer configured to use any software that is available in SlapOS. And this one is for prepare the machine's positions and folders and so on. So you have an API when you install SlapOS, you also have a command line tool that allows you to supply and request and use a console to automate the deployments of the softwares that you want to deploy. So here is an example of a request and a supply. So I'm deploying a software release of monitor to a computer, and then I'm requesting to run one instance of this monitoring on this computer. So it's the equivalent of setting a monitor for a wind turbine, for example. Here is just variations of the services, of the requests that you can be done. So when you deploy this monitor, you already deploy FluentD, which is what collects the logs from the machines. Which leads me to the Wendelin part. So as SlapOS is everywhere and it's standardized in a way that we can put it anywhere. So we were able to quickly deploy a Wendelin stack, which is a tool for provide big data analysis and out of core Python. And the advantage of using SlapOS in this case, it doesn't require hours of setup to have the stack. So even a data scientist which has no background on setting a cluster can set up it. And also allows the persons that which are not data scientists have the full stack of, for example, Scikitlearn, NumPy, out of core, distributed database, and Jupyter notebook ready to use for make some kind of calculation. So both sides can benefit from the quick setup by not expending time on learning how to pip install NumPy on REM in your Raspberry Pi, or examples like this. So the Wendelin also was designed to work on commodity hardware, so it don't requires a super powerful machine to be deployed. So you can, keeping the dimension of what you are going to do, you can make big data with machines that you can buy in supermarket, for example. You can buy a few machines i7 in a supermarket, then you can start to make big data. Because it's quite easy to find one i7 with a 16 or 32 gigabytes of RAM anywhere. And SSDs are becoming cheaper and cheaper. So you can buy a 1 terabyte SSD these days quite easily. And as everything was designed to be distributed with SlapOS, you can buy several cheap machines and then you have big data. You don't have to expend 100,000 euros buying expensive hardware to start to make big data. So the stack is composed by average hardware. Of course, people that has conditions can buy more reliable hardware, but it don't requires a special servers for it. So we use SlapOS. The EuroPython is just as a base tool with Neo to provide an object database that we are going to manipulate soon. And the Scikitlearn is to provide machine learning and other features that you can use in big data. And the EuroPython is also used to provide one already old but equivalent tool compared to the joblib. So we already had distributed and active, what's the name in English? So it's active. So we can provide a background and asynchronous we can do a background and asynchronous programming already by 10 or 12 years. So since I started, they're already doing asynchronous programming. So, but the stack is nothing if the data don't arrive there. So you can only do big data if the data arrives to the tool. So we use FluentD mostly because it's one of the most reliable tools that exist today. We make a test in the office when we were selecting, and we put a laptop in a normal our normal office, and we let it on during the weekend, pushing data to the Wendelin, which is the case, but we are not analyzing FluentD. And it could last just one registry over 1 million in the space of 2 weeks, which is very, very reliable, because the laptop is turned off and on all the time, because suspended, enabled, and the person go home with the laptop and connects from the other network, and then it turn off, suspend and enabler, goes to 3G, then goes to Wi-Fi again. So all of this is just lost one registry. And for the places which we cannot afford run FluentD process, we can just run an HTTP, and we can on the HTTP server, and we can crawl with a FluentD. And what we extend FluentD on this case is to stream binary data, because I will show soon. But we can stream wave sounds in a wave.wav format to the Wendelin and plot an FFT out of it. So how we deploy, so here we learn how to request into whatever computer monitor which will come with a FluentD. And here with just 2 lines we can request the Wendelin. So the full stack with all tools and Scikitlearn, NumPy, Wendelin Core, out of data. There is several other scientific tools installed on it. Is available just by typing these 2 commands in whatever node you want. Or if you are in a standalone fashion, you don't want to connect, you want to just to have an instance in your VM in Amazon, you just type this command and you get everything. So soon we are going to release, it was not ready for this conference, but soon we are going to release ready-to-use images for QEMU, EC2, and DigitalOcean, VMware, VirtualBox, and so on, which can provide ready-to-use, ready-to-try, I would say, instances of Wendelin. So you don't have to pay yourself for install Big Data anymore. So here it render the tags. I will show from. So here is the configuration. Here is what I ran earlier today to upload the data. So you generate a file which is basically like this, which says look at this folder for wave files, save the position to know what you already sent or not. Then you can tag your data. You can have different tags for different data and send to different ingestion policies to you classify or shard, or you can do whatever you want with your data. And here I just use the Wendelin plugin, which is already come with the monitor that I just said. But if you if you are just installing the FluentD from Treasure Data, you can easily install. It's just a file in a folder. Then you say where you are sending to, and which is the user and which is the password. And here you can see that it found 6 waves. Yes, 6 waves, and it streamed everything to this ingestion. So in few minutes you can start to ingest files in your big data. So probably it also works with the other equivalents of FluentD, like logstash, and I forgot the name of the other one, which is also written in Ruby. So you can write plugins which are compatible just by making posts and making sure that you already have, you are consistent when you send the data. So I come back now. So this is what I just showed. You can limit the buffer and so on. If you buffer in memory, or if you had too much streaming of data, you can buffer in disk. And you can just run manually like this. Just FluentD, let's see, and then you pass the configuration file. or you can, or depending of your setup, or if you are using SlapOS or not, you can write a very complex configuration file. So it takes just a few minutes. Yeah, this was just what I showed. When you run, it will just say that you send data. Then if you are using different plugins for example, to get syslog or machine consumptions that we use to, it just use a different, you have just to adjust the part of the source. I can show another examples later if I have time. So, where the data goes? So I will just jump quickly. Up. So the data goes to these. So this is the UI of EuroPython, which will be able, will just store the data, and by using a fast input, you can create the entirely path to be ready to use that configuration file that you saw. So it will create a portal ingestion that you can use Python to, for example, if the tag is, depending of the tag, you can write in a different data streams. I'm not doing anything complex here. What arrives, I just put in the same stream of data. So I can just go to data streams, yes. So I can just search for wave. So here I have my wave that I sent earlier with the amount of data. I can manually upload a file which will overwrite the file that is already there, overwrite the data that is there, and I can append files manually. So you don't have to only rely on the FluentD to send data. You can upload certain data that you have to manipulate, or you can make posts, for example, to upload a certain data store that you have. Then, how to use this data? So I have, this data represents several wave sounds that was streamed to this computer. I will just show data arrays after, when I'm starting to do demos. So here, a demo. So I installed SlapOS everywhere. I have my Wendelin setup. So if you are in normal speed, you can set up everything in one day or less. And I go to my demo. So I hope I still have IPv6, else I will not make demo, but just show the thing. And believe it or not, I have IPv6 here, even if you don't. So instead of use the normal IPython, we just make a small extension to the normal IPython notebook. Not the entire tool, but we just create a different kernel that we can use with some magic, which can make our life easier and to be more reliable when we deal with data. So I assume that you know minimally IPython. If you get lost, raise your hand, because that will be time to do it. So some magic. We just this 1, 2, 4. We just say where we are going to connect our notebook. So it's just a reference. Then when you finish, you get an object called context. you can see it as a kind of proxy. It's not exactly a proxy, but whatever you put contacts.getID, you are doing a remote call. Let's see. Okay, I don't have IPv6 now. I have, maybe. Let's see. Yes, I have, again. So, I can just call whatever I want. I'm doing a remote call to that object. I don't have a relative URL. So, based on this, I can get the data that I streamed. So the data that you saw, it's under this path. But of course, nobody remembers the ID of every object that you want to manipulate. So you can search the object by using the catalog. So you can make queries to the database to know where it is, the paths, and so on. So you can just use portal catalog. Then it starts, this is an interesting part. So, even if it's out of core, you are not calling the methods on the IPython notebook, but you are doing a remote call to manipulate the objects. You can still do bad things. So, for example, this gets the entire data which is in the stream. So, if there is 1 terabyte data, it will get everything as string to your browser. Not good at all. So the only thing that you have to take care is to use different approaches, not so much different, but you have to take care to not load the data all at once when you want to manipulate. Here is just 2 examples that we are on core, that we are making the IPython notebook handle all the data, and here we are just managing small chunks of data. Here is just few imports because I have to import SciPy to handle the waves that I want. Then I wanted to make an FFT without load entire data. And for this, if you read the code of this read function, it will expect that it's a file. As I expect that it's a file, I could use the file I.O., the string I.O. of Python. However, if I use the string I.O., I have to load the entire data to give to the string I.O. That's why I make this class as a wrapper to make an out-of-core stream looks like a file. So when I pass the file reader, it will behave like a file, but without loading the entire data. Because you can imagine that the data can be 1 terabyte. In this way, by using this file, I can manipulate a 1 terabyte file as it is an average file without requires me to have 1 terabyte of memory. So here I just get 1 channel, and here I'm just saving. Oh, I'm running out of time. So here I'm just saving the arrays and plotting it. So I'm just plotting the arrays and making FFT here. So I get the array, I save the array, I re-get the array in order to make it out of core, and then I save it and I plot. I can save images too to the database. Yeah. Up. So here was the previous times that I invoked the FFT, so I can see the files. Oops. Or I can re-get much later one array that I already processed and replot it. So I can save and recover the arrays that I'm using. So then I move to the second demo, which is now I'm going to emulate an asynchronous processing using, oops, I click, okay. So it's the same thing as before. So here I make just a calculation to see how much data I have in the site, 33 gigabytes. And here I just make the same calculation, saving the calculation 10 by 10. So I put in background processing. I will just, oops. So I'm just putting in the background the processing, and later I'm checking if the processing is already finished. Then I can make the same calculation again, but doing a kind of map reducing and using a cluster of instances instead of program myself in the level of the IPython notebook. So this is the kind of things that you can do after 1 day of setup. So I already did asynchronous very quickly. So you could do directly, so you can follow the tutorial in the link. I will make it available at Twitter to the site. So you can make the tutorial in the link for plot data directly in the browser using JavaScript. There is a short tutorial. And you can use pip install and use the core of Wendelin without install the full stack. So you can use Wendelin and out of core features just in your computer to make small calculations which exceeds the run that you have in your computer. Well, thank you very much. I was extended a bit, sorry. So now I think it's a coffee break. I steal a bit of your coffee break. So if anyone has questions, can ask or feel free to go to coffee break.